animated pressure surge results using KY pipe. This is an effective way to evaluate pressure surges in a piping system for engineers and utilities. In this computer animation, we are looking at an example of a system pumping from point A to B. This is not a distribution system. The pump is on the left, and the pipeline length is shown along the bottom, which represents roughly 5,000 feet. Some profiles are more flat than others, but it's the same concept. When the pumps are running, the line is pressurized, and the green line, which is the hydraulic grade line, also known as HGL, shows the pressure along the length of the system. The pump is at approximately 75 feet, and the HGL is at approximately 260 feet, which gives us 185 feet ahead, or 80 psi pump discharge pressure. Looking down the line, we can see where the pressure is all along the line. Now let's simulate a power failure or pump trip e-stop scenario. As we can see right away, we have a negative pressure traveling down the line, which is traveling at 2, 3, or 4,000 feet per second, depending on the pipe materials. Everything below the pipe is negative pressure, and when it bottoms out, the pipe is experiencing full vacuum, which is negative 14.5 psi, which you can see the pressures along the top. Everywhere in black is where water column separation is happening. The water column separation is forming vapor pockets, and when these collapse on themselves, we will see that high pressure spikes will begin to generate throughout the line. Let's pause here for a second. Our original discharge pressure was 80 psi. Now look at where we are at. This is all due to those vapor pockets forming and then collapsing on themselves. Now let's look at the same system with a surge tank installed. You can see the HGL begins to slowly drop. However, a little over halfway through this system, we are experiencing negative pressures that are a little over what is considered acceptable for this system and the pipeline materials. A very important consideration when applying a surge tank to a piping system is to consider the check valves being selected. As we can see here, the lever and weight with an air cushion actually had a pretty good slam once pump trip happened at the station with the surge tank installed. Now let's look at this animation with a surge tank installed, along with an air vacuum valve out on the line. As we can see here, the air valve is activated and is functioning as it should. We also selected a different check valve for this application, of which we can see we barely have any slam happening at all during a pump trip. If you haven't guessed by now, this is a force main system example, not a potable water system. So the negative pressures that we are experiencing are acceptable for this application. In conclusion, a surge analysis is best to be performed to ensure proper mitigation efforts are taken under all operating scenarios. Hey, you made it this far, congrats. So maybe you're an engineer or part of a utility. Perhaps you have a system that has never been hydraulically modeled, let alone a surge analysis performed. Monitoring your system with a high-resolution transient pressure sensor would be a step in the right direction. This data will help calibrate the surge analysis later on. You may be surprised at the other benefits as well. Check out the link in the description below to find out more.